Algebra 1 skills number 14, solving systems of equations. And this time we're going to look at it from the substitution angle, which is not the most popular method, but there are times when the substitution method is the easiest. So let's take a look at first of all, what is a system of equations? A system of equations is two or more equations that have the same variables. Okay, so you see two different or three different equations, and the equations or variables you see within those equations are the same variables. Okay, so that's a system of equations. The process to solve a system is, this is specifically the substitution process. Isolate a variable in one equation. Now, for our purposes, and my recommendation is, I'm not going to do substitution unless one's isolated anyway. So this step one may be unnecessary. My two examples here, this is not going to be necessary, but there may be some cases where if it's really easy to isolate a variable, then substitution would be an okay way to do it. But you want one of the variables in one of the equations to be by itself. We're going to substitute into the other equation, and we're going to solve for the remaining variable. And that, of course, to solve a system, you need to know both variables or all the variables. So we're going to back substitute the original equation. Now this will make more sense with a couple examples. Let's do that. So here's a system of equations. Now we color coded this, the same x and y in each equation. Okay, so notice though that this red one has y by itself. That's what you're looking for substitution. If one of them is by itself or really easy to get by itself, then substitution is a good way to go. So y equals 2x minus 1. And notice I put that y red in this one too. Because what we're going to do is take this part here and we're going to plug it into that y. Okay, so notice again, follow color coding. What I did was take the yellow equation and write it with y gone and 2x minus 1. So we're down to one variable. Okay, we substituted equals for equals here. And now we're just going to solve for that variable. So we have an equation. We want to distribute. We want to combine like terms. Next slide. Now we have a two-step, subtract 4 from both sides, divide by -6. So x equals 3 is part of our solution. Now to solve a system, we need the value of the variables, multiple variables, that satisfy all the equations within that system, not just one. So keep that in mind. We now need to back substitute. So I wrote the problem. This is not color-coded. This is the same problem. And we know that x is 3. Okay, so what I did was take 3 and plugged it into the top equation. You could plug it in the bottom one. It's just easier to plug in the top. So I plugged 3 in for x, and I'm just going to evaluate that. So 2 times 3 is 6. 6 minus 1 is 5. So x is 3, y is 5. So we usually write our solution as an ordered pair, 3, 5. 3 for x, 5 for y. So in order, as the name implies, x first and then y. Second example. This time x is isolated. Okay, it doesn't have to be y isolated. We're used to slope-intercept forms. You see y isolated more than x, but the x could be isolated too. So again, same setup. This time we're going to put 3y plus 4 into x. Now I put it in parentheses. You don't really need the parentheses because there's nothing being multiplied, but the parentheses just kind of show what happened. Now we're going to do the same thing. We're going to solve for y this time. I know x is generally what you solve for, but this time y. Again, the parentheses don't really mean anything. 3y minus -4y. It's -1y plus 4 equals -5. Okay, same problem. Subtract 4 from both sides. And what I did here, maybe a little subtle, if you see an awkward negative like that, of course, we could have put -1 from the beginning or a step ago. But if you ever see a negative in front without a number, just put a 1 in there. That really clarifies what to do. So now I can easily say I'm dividing by -1. So y is 9. Okay, so just like before, original problem, and I'm going to put 9 into this one. It's a little easier than putting it into that one. So I replace 9 for y this time. Again, for y, not for x. 3 times 9 is 27. 27 plus 4 is 31. So our ordered pair is 31, 9. Even though we found y first, we want to put x first and then y. So solving a system with substitution.